All right, two-dimensional figures, and we're going to talk about a polygon. Is a closed figure. Formed by a finite number of segments. I'll answer that in just a second. Finite number of segments called sides. Finite is the opposite of infinite. You know, infinite goes on forever. Finite, it has to stop. So the number of sides, there has to be a number of sides for a polygon to be a polygon. It can't have an unlimited number of sides. It ends up appearing to be a circle, but by definition, it's still not. Because the sides are segments. Segments are straight, whereas a circle, by definition, is made up of an infinite set of points equidistant from a given point. But as you keep taking a polygon and adding sides to it, it looks like a circle. Let's see, polygon closed figures. So when you're looking at a polygon, obviously this polygon has 5 sides. All right, so here's your sides. Can't believe I'm even writing this down. Right? And yeah, exactly. And here are your vertices. Where the sides meet, right? Those are your vertices. The number of vertices will be equal to the number of sides in a polygon. All right, next on the list of wonderful facts and definitions for today in this section, we're going to talk about concave and convex polygons. It's one way to classify a polygon. You can write the definitions down out of your book if you want to, but I'm going to show you the only way I was able to ever remember it. Concave. I can only remember it by the way they looked. So a concave polygon is one that looks like this. Or this. And to me, what I picture is somebody caved in one of the vertices. And that's how I can remember the difference between concave and convex. Because to me, this vertex right here, it got caved in. Make sense? Yeah. Because the difference would be convex. And in a convex polygon, I mean, if it's a triangle, You know, if it's a quadrilateral, pentagon, right? To me, the difference in this set of shapes is very distinct from these shapes. Okay? So, if you need the definition, it's in the book. If you want to remember it this way, that's the only way I could ever remember it. Top of page 57. Let's write this table down first. Number of sides. And then the name of the polygon. So three-sided, hopefully you know it's called a triangle. Four-sided, it gets called a quadrilateral. And then 5 is a penta. 6, hexagon. 7, heptagon. And we're going to go to 10 because that's what you need to know. After 10, you don't need to know the names anymore. So 8 is stop sign, octa, or hot tub. Nice 8-sided hot tub is very, very comfortable. You know what it looks like? Just like a stop sign. 9 is a ninagon with an O, so it's called a nonagon. Right? And then 10, that's called a tenagon or a decagon. Now, you do need to know those. I mean, and you probably know most of them or all of them. I mean, hepta isn't used that often. So that may be one you got to do a little thinking on. Okay, so now we go to an n number of sides, and that's called an n-gon. Okay, and what that means is that if something has 14 sides, you just call it a 14-gon. Really what? Really plain, I know. I mean, just think if you were a 32-sided polygon and all they're going to call you is a 32-gon.
I would be pretty upset.
You would be upset. I mean, you would want to feel like you need more of a special name.
It said 32 gon, like, what is that?
But if you go and do a little bit of research, there is an actual name for it, but I don't know what it is. And I'm going to call it a 32-gon. Okay? You can go memorize the list to, you know, infinity if you want. I'll give you extra credit. Probably not, though.
Yeah, how much extra credit?
None, I'll just say that I will and then I won't.
Then,
Can you go back up?
Go back up? Yeah, where you at? Penta and hexa. Oh, I'm sorry, quadra and penta. They're in the book on the top of 57. They go to 11-sided is a hendecagon, and 12 is a dodecagon. Okay, a couple more terms. Equiangular. Equiangular means all congruent angles. Equiangular, all congruent angles, or equal angles. Equilateral. All right? That's equal sides, or all congruent sides. Equiangular, equal angles. Equilateral, equal sides. And then, this is important. If a polygon is equilateral or equiangular and equilateral, then it is regular. And that's kind of disrespectful as well. You know, if you were a shape and all your sides were the same and all your angles were the same, you would just be regular.
So like squares.
Everything.
So like a 14-sided shape.
So the picture would look something like, remember the tick marks that told you segments were congruent? And then arc marks that told you angles were congruent? In this case, triangle ABC, or if you were asked to refer to a triangle ABC, or find the perimeter, or find one side length of triangle ABC, and it's regular. All right, it means that all the sides are the same and all the angles are the same.
So if you see that, then it's regular.
Correct. The only other thing left to cover in this section is on the next page, perimeters, circumference, and area. All right, let's say that the perimeter that's the sum of the sides, right? Sum of the length of the sides. And we got to cover circumference. And that's your distance around a circle. And then area. Area of a polygon. That's the number of square units needed to cover the surface. All right, so one more table. we'll call it the shape. Then we'll list its formula for perimeter and area. We'll start with a triangle. The perimeter of a triangle that's an S, is the sum of the sides. Side 1 plus side 2 plus side 3. Area of a triangle, that's equal to 0.5 times the base times the height. Here, this is real important. Base and height. Are always. What does that symbol mean? Perpendicular. Base and height are always perpendicular. Don't ever forget that. In any and every shape, when you're dealing with the base and you're dealing with the height, whether it's two-dimensional or three-dimensional, the base and the height, those dimensions are always perpendicular to each other. They always intersect at 90 degrees. Anytime you're using a formula that deals with base and height of a shape, and you pick your base and you pick your height, make sure those two segments are perpendicular to each other. If they're not, one of them's not the base and the other one's not the height. Those two dimensions have to be perpendicular. So on a square, the perimeter is equal to 4 times the length of a side, because all the sides are equal. And the area is equal to one of the sides squared. In a rectangle, the perimeter is equal to 2 times the length plus 2 times the width. And the area is equal to the length times the width. In a circle, the perimeter is also known as the circumference. There's 2 formulas for the circumference of a circle. One of them is 2 times pi times the radius. The other one that you can use is pi times the diameter. Either one, you're going to get the same answer. Because isn't the diameter just 2 times the radius? Okay, so 2 times the radius is the same as diameter. The area of a circle is equal to pi times the radius squared. You have to square the radius before you multiply it by pi. You have to square the radius before you multiply it by pi. And just because, we'll just do a quick review on a circle, right? this dimension that goes from the center of the circle to the side of the circle. What's that called? That's called the radius. And then you've got a dimension that goes from one side of the circle to the other side of the circle, and it goes through the center. And that's called the diameter. Diameter equals 2 times the radius. Radius equals diameter divided by 2. Yes?
Does it matter which one you find first?
You're either going to be given the radius or diameter, or you're going to be given the circumference. Okay? If you're given the circumference, you can solve for the radius. Yes?
Can you go over rectangle again?
This one right here?
Yeah.
What did you say? Go over it again?
Yeah.
Yeah, right here on the rectangle. You'll see it actually a couple different ways. Okay, length right here and width. So your perimeter equals 2 of the length plus 2 of the width. And the area equals the length times the width. If you see it, and you will, but I think it's pretty far along later in the book, this might be listed as the base. All right? And if it's listed as the base, what will the width be listed as? The height. Okay, so base and height. So, or this would be 2 times b plus 2 times h in that case. And on the area, it would be base times height. Any other questions? All right, your assignment for today is on starting on page 61, 11 through 16, and then continuing on the next page, 17 through 24. And then, as always, check the odds and deadline. Check your odds and deadline.